The integral from 1 to infinity of 1 minus x times e to the negative x dx. Finding the antiderivative, which we ultimately have to do after we write the integral as a limit, might be a little harder here. So let's get that out of the way as kind of a separate piece to this. So let's take a timeout. And just since it might take a little bit of work, it won't be too bad. Let's find the antiderivative separately, so we don't interrupt the flow of the problem when we evaluate those limits. So we don't interrupt the flow of that too badly. So this is a good review for the exam, integration by parts. How do I know to use? How did you know, Christian, to use integration by parts? Yeah, linear. More specifically, it's a polynomial function times a transcendental. When that happens, a lot of times you try integration by parts. And in fact, what are you going to call u here? Yeah, 1 minus x. And dv? I gave it away. dv is e to the negative x dx. And the proper formula, integral u, that you're going to have memorized by next week if you don't already. The integral of u dv equals? And by the way, if you memorize this, it tells you the steps you need to follow. The formula whispers to you. You just have to listen to it. It tells you, the left-hand side tells you, oh, you need to find a u, and you need to find, name your u essentially, and name your dv, which we did. And then the right-hand formula tells you what you need. Yeah, you need the u and the v, but and the du, some of which you have, some of which you don't. In fact, you don't have the v yet, and you don't have the du yet, so you have to find those. So here's the way I like to do it. I like to write down my u, and then based on that, what is my du? -1 or just negative dx. And then I like to write down my dv, e to the negative x dx. So what's my v? Negative e to the negative x. Okay. So now plug in the right-hand side. So what does this integral become? U times v. What's a good way to write that, though? Yeah, negative e to the x times, oh, yeah, negative x, you're right. And then times 1 minus x. So that's actually v times u, but who cares? Minus integral v, right, v to u, right? So what's that? Yeah, we'll simplify that in a second. Negative e to the negative x, and then what is du? You could think of it as -1 dx if you like, right? So when the smoke settles, what operation we're going to have out in front? We've got three negatives there essentially, right? So it's going to stay negative. And if I multiply this out, what do I get? X e to the negative x is the nicest way to write it. And then it'll stay minus integral of e to the negative x. Does everybody agree with that? And then you integrate that, and what does it become? Yeah, it'll be positive e to the negative x, because when you, whoops, dx here. When you integrate this, you get negative e to the negative x, but you have a minus on the outside. So it'll be on the end, it'll be plus e to the negative x when the dust settles. I suppose if we were just looking for an antiderivative, it'd be plus c at some point before you finish, right? But what's going to happen to this guy and this guy? It's really plus e to the negative x, and this is really negative e to the negative x, gone. So you just end up with x e to the negative x plus c for your general antiderivative. Of course, the one we're going to use is x e to the negative x. Okay? So we found our antiderivative, so let's get back to what we're really studying in this section, which is evaluating an improper integral. So here's the integral. So this is a time in, I guess. Time in. Timeout's over. Okay, so we've got our antiderivative. It's that guy. We're going to use that in a second. But first, how do I rewrite this? Limit b goes to infinity. Integral 1 to b 1 minus x e to the negative x dx. Okay, and then we can go right. We have the antiderivative, so we can go right to the part where we evaluate it, which is kind of nice. The limit b goes to infinity. Okay, the antiderivative of this is x e to the negative x inside evaluation brackets, and the evaluation brackets go from 1 to b. Right? Plug in your upper limit, apply the fundamental theorem. What do you get? Okay, so b e to the negative b minus, so 1 over e. Yeah, it's, yeah, when you plug in 1, you get 1. You get 1 times e to the negative 1, which is really and a minus in front, so minus 1 over e, right? That's a nice way to write it. 1 over e is a nice constant. It's not going to affect whether or not this quantity in the brackets converges, right? So let's concentrate on the b e to the negative b. In fact, if it does converge, then there's no reason why we can't write the minus 1 over e on the outside. Okay, now that the limit, concentrate on the limit. We have to carry along the minus 1 over e, because if it does converge, then that's part of the answer, right? If it doesn't converge, it's all nonsense anyway. It's not nonsense, it's just the answer is it doesn't converge, right? So what's the indeterminate form then for this guy? Off to the side, write it down. Or is it an indeterminate form? Well, yeah, what is b doing as b goes to infinity? B goes to infinity. And what is e to the negative b doing as b goes to infinity? Goes to 0. So you have the epic battle between the two titans, infinity and 0. Who's going to win? So yeah, it's an indeterminate form. But it's not the right indeterminate form to use what? L'Hopital's rule. To use L'Hopital's rule, you got to have either plus or minus infinity over plus or minus infinity, or 0 over 0 as an indeterminate form. Well, I think hopefully there's an obvious thing to do here, an obvious way to rewrite it. Yeah, make it the limit. Make it the limit as b goes to infinity of b over e to the b. And then, of course, we still have on the outside minus 1 over e. I kind of dropped the brackets there. Now is it the right form, though? So certainly you still have infinity on top. B goes to infinity. What about e to the b? That goes to positive infinity as well. So yes, that's the right indeterminate form. So I do require that sort of work here, because that tells me you know when to apply L'Hopital's rule. And then in the next step, I'll put an equal sign and then an h, just for your benefit. If you want to put that down, it would help me too, especially if I know you're trying to apply L'Hopital's rule, but you don't apply it correctly. At least maybe I can give you partial credit because you knew to try it, right? So okay, so I do that, and what does L'Hopital's rule say about this limit? The limit of b over e to the b is the same as the limit of, take the derivative of the top, the derivative of the bottom, with respect to b, with respect to the variable that that's approaching infinity, I guess. And is that easy to evaluate? Don't forget the minus 1 over e. Is this limit easy to evaluate? What is it? E to the b is going to infinity. And so 1 over e to the b must be going to 0. So we get just negative 1 over e, and the improper integral converges. Does that make sense? So that one took a little more work because the antiderivative wasn't as easy to find as some of the others.